Is it audible? Okay, I'll go with the next problem. This is the last problem I'll be solving. Give me a moment. Any problem you should be able to solve here onwards. Should not be difficult for you. Give me a moment. This problem is on UVL, uniformly varying load. Okay, this is a 5 meter length, and the load in the sense this height. This is 10 kilonewton per meter. Okay, this is point A. Point B. First, we need to find the reactions. Summation of forces in y direction equal to 0. There is a reaction force Ra acting upwards, and due to the cantilever, there is a sub moment EMB in the counter level. You can assume any direction. Ra also you can assume direction, not measure. Okay, and finally we should to change the direction. Therefore, Ra acting upwards, UDL acting downwards minus half into B is 10, height is 5 is equal to 0, Ra which is equal to 25 kilonewton. Moment about A is equal to 0, which is equal to, I can write this as minus MA. If this is the centroid, entire load is concentrated here. Entire load of magnitude half into 10 into 5 is concentrated. 25 kilonewton is concentrated at this point like this. 25 kilonewton load is concentrated like this. Okay, minus MA. The magnitude is minus, this is minus MA, this is causing clockwise moment, like this clockwise moment, plus half into base is 10 into half into 10 into height is 5, and the distance half into 10 into 5, that is nothing but 25, and the distance is h by 3, which is equal to 5 by 3. MA, which is equal to 25 into 5 by 3. Can you tell me what is this value? 125 by 3. How much?
41.6.
41.6, 41.67 kilonewton meter. Okay, my MA is in counterclockwise direction. We also got positive 41.67 kilonewton meter. Hence, it is the whatever the direction we have assumed and the value we got is is the same. It is in the same direction. The assumed direction and the obtained value is same. Therefore, this MA is in the same direction what we have assumed. Okay. Next, I can write says 25 kilonewton, 25 counterclockwise 41.67. This is you can write 10 kilonewton meter, 10 kilonewton per meter, 10 kilonewton per meter, uniformly varying load, A, B, parametric. I'll pass a section here. X1, X1, there is only one region. If the number of region increases, segment increases, then only there will be four segment. It will take some much time. If there is no UDL, that is much easier. Okay. Now, all right. Uh, segment figure SFD and BMD. Segment AB x greater than or equal to 0, less than or equal to 5. Now figure, this is the figure, 25 kilonewton load, 41.67 kilonewton moment. This is section XX. Okay, and at the centroid, at the center, at the center, there is a load of, there is a magnitude of into base is 10, height is, in our case, if this is x, this is x, this is the height, of into 10 into x, of into 10 into x, and this distance will be x by 3. If this is the x, it is from the center. If this is the UL, this is sorry, 2x by 3 into 2x by 3. Okay, this is the UL, then this will be h by 3 and this will be 2h by 3, so that entire it will become your whatever this x, h by 3 plus 2h by 3, which is nothing but equal to h, or is equal to x. Okay. Next, F is equal to summation of vertical forces, which will be equal to acting upwards 25, acting downwards minus half into 10 into x. F at x is equal to 0 is equal to 25 kilonewton. F at x is equal to 5 is equal to 0. Okay, half into 2 5 is 10, 5 is 25, minus 25 plus 25 is 0. Okay, moment at moment is equal to summation of moment about xx, which will be equal to this 20, this is 25, right? 25 x, which is bending the wave like this, which is smiling face, This is counterclockwise. This is the shape. Clockwise from this will be positive. This is the this is anti-clockwise will be negative. This moment some suction is here. This is acting counterclockwise. This is negative. This is positive. Therefore, minus 41.667. This is bending the beam like this, which is negative. This 10x minus half into 10x is the magnitude into 2x by 3, or which is equal to 25x minus 41.667. 2 cancels, 2 cancels, minus 10x square by 3. Write it here. Moment at x is equal to 0, it is equal to minus 41.667. Moment at x is equal to 5. Can you tell me 125 minus 41.667 minus 5 5 25 minus 250 by 3. Also, you should remember, if you get a small negligible value, minus 2.34 into 10 power minus 3, or 2.3 into 10 power minus 6, something like that, it is equal to 0. You are almost equal to 0 at the extreme and right extreme end. Tell me this value. 125 minus 41.67 minus 250 by 3. How much? How much? How much are you getting? Yes. Tuti, how much are you getting? Nikala?
minus 0.0033.
Minus?
0.0033.
Minus 0.02. Tell me once again. Minus
0.00033.
0.33. It is equal to 0, or it is equal to 3 point into minus 3.3 into 10 power minus 4, which is 0. Okay. Now we'll see the variation. If then if this is a load diagram, how would be the shear force? This is linear. Shear force would be quadratic. You should remember that. Shear force will be quadratic, and bending moment is cubic. This is load diagram. Shear force at x is equal to 0 is 25, and then x equal to 5 is 0. X equal to 0 is 25. This is 0. You check it out how how this variation will be. This is how the variation is, like this, right? Like this is the variation. Therefore, sorry, how the variation is 25, 25 is like this. Okay, okay, load diagram, I have to look into that. Load diagram, if you see, load diagram, load diagram is like this. This is negative something, negative value going like this, negative value going like this. This is AB, negative value. This is similar to this diagram. Therefore, this is the curve. negative value. The load that UVL is negative, right? UVL is negative in the sense minus 10 kilometer meter acting downwards like this. Therefore, this is the load diagram. The for instead of UVL shear force, if I take this UVL as the diagram, then this is the curve will be like this. This curve. Okay. Therefore, this will be this is quadratic or parabolic. And moment, there is a moment here, there is a moment here, and also point for point A. Due to moment, there is a sudden shoot up of the bending moment, which is equal to minus 44.67 at this point, at this point minus 41.667, and then at x is equal to 0, this will come back to 0. Therefore, this is a cubic curve. Draw a curve like this. That's it. Cubic. Indicate it as cubic. Completed almost all types of problems. Any doubts if you have, you can approach me. Okay, and yesterday I sent you one problem. That is how you have to solve in the examination. Okay, you will be having two problems in module 3. One problem will be full complete 20 marks, whatever the full one problem for 20 marks, and the other problem will be for example, write the types of beams, write the types of support, what is a beam, what do you mean by bending moment, what is shear force, write the equation relating bending moment and shear force, derive the equation relating bending moment shear force. That is one question, part A, for module 3, part A, and one simple problem will be on that. In that model 3 part B, one typical problem, one standard problem of full 20 marks will be given, or two problems in case. That's all you can ask. I completed everything in model 3. Any doubts, if you can approach me. If you want one more class tomorrow, I will take, and one or two problems if we will solve. From Monday onwards, we will solve the fourth module, the bending of beams. Okay. Any doubts you are having? Abdul Razak, Dhruti, Mekala,
Yes, sir.
Pratish, Paul, Raghavendra, Rakesh, Sushil Kumawat.
Sir, I will work on it, sir. If I get doubt, I'll just contact you, sir.
You please work on it. I will also share my PPTs. I will also share my PPTs in GCR. You work on it. You just look into this. You practice the problem what I have done. Just first see the problem how I have done. Practice in the same way. What you should know is when for a UDL or UVL, when the suction passes through the UDL or UVL, that is one of the concept. The second concept is when the suction passes away from the UDL or UVL, how you will take the moment. These two concepts if you are then you can easily solve the problem. Okay, I'll stop at this point. Thank
Yes,
you.
sir.